a background in civil engineering, so he's been working on water problems for a long time, and I think we're ready to go here, Hernan. Get your full 5 minutes, so don't worry about that.
Appreciate it. Thank you. All right. Great. Today I want to talk about using hyper-resolution hydrologic models to understand and predict water. And we're combining those models with remote sensing information from different platforms, satellites, UAVs, or what we call smart sampling systems. It's not only me, it's a lot of people behind me, including postdocs, grad students, and some other undergrads that we're working with right now. A lot of exciting lines of research, including other faculty here, Tom, Yang, Jeff. But the 5 main lines of my research as of today are focused on improving hyper-resolution modeling for watershed predictions, number 1. Number 2, understanding the hydrologic effects of forest disturbances, namely tree infestation, namely forest fires, namely deforestation, urbanization. Number 3, we're focused on understanding real-time river flood forecasting, the reasons, the main triggers of the excessive production of runoff in some areas. We're also working to understand the spatial and temporal variability of soil moisture and evapotranspiration, okay? And finally, we're doing our first steps on developing unmanned aerial systems for tracking bathymetry in reservoirs and lakes, developing amphibian models of flying and floating systems to estimate water volume. But not only that, but we're also working towards tracking soil moisture and evapotranspiration from the air using drones. Here is our basis of our knowledge is to try to understand processes. Beyond anything else, we want to provide the right answers for the right reasons. So our main focus is on developing models like this, calibrating them, understanding every process, getting the ballpark results, and we try to introduce all possible information that we have available. With time, we've been getting more and more information, topography, land cover, soil types, and we want to take advantage of. So we now can understand better the processes. And so our models reproduce the coupled beta zone and saturated zones, runoff mechanisms, channel routing, water and energy balance, and snow processes. This is the type of model we use. A distributed model that works in a thin geometry that is more efficient to replicate changes in terrain. And this is one of the experiments we conducted in Arizona where they're planning to conduct deforestation, control deforestation, what they call prescribed burdens, and forest thinning. But we did an experiment in running the hydrologic model for 10 years and see what happens in a scenario of less trees. Less forest mean less interception, for example, and different conditions for runoff generation, and different conditions for snow accumulation, because there's more radiation coming to the ground that could melt the snow faster. This area in Arizona depends seriously on the snow melt process and occurring in early spring. In a scenario of less trees would mean earlier spring melting seasons. This is the type of results we can get with our models. Of course, decision makers and policy makers meet frequently with us and take a look at the maps that we obtain, the projections, and they make decisions accordingly. We're also using our models to introduce radar nodecasts into and then get predictions of flow. We in a recently paper, we found out that the basins that are less predictable are the middle-sized basins that coincide with the size of the clouds, not the small, not the largest one, but the middle-sized basins. I'll have 30 seconds. And we're also working with the Army through a Young Investigator program to try to create Mesonet virtual eddy covariance towers to explain the evapotranspiration fluxes in those areas. Like I said before, we're also working to develop a drone with a radiometer on top to track soil moisture fields. We already have the setup mounted in Kessler to start testing the system, and this is our newest development. Instead of a regular Phantom carrying a sonar boat that can track where the lake bed is, we're also working on an independent boat that can make the measurements without the need for the flying system. We're planning to introduce all these measurements into distributed models. So we believe the combination of both will get us to get the right answer for the right reasons. I think that's 20 seconds. I still have 20 seconds. Any questions or comments?
That's bad.
Good.
It's red
Okay.
flashing.
All right, okay. Thank you.